Bismillahirrahmanirrahim. Let us start the electronic distribution. Now, in order to understand the distribution of electron in an atom, we must have an idea about various facts. जैसे कि एक ऑर्बिटल में कितने इलेक्ट्रॉन आ सकते हैं, इलेक्ट्रॉन को जब सेट किया जाएगा अकॉर्डिंग टू विच रूल्स किया जाएगा. How many maximum electrons can be accommodated in a shell or in a subshell? So, an orbital like s, p, d, f या px, py, pz can have at the most 2 electrons, not more than 2. Another important point is the maximum number of electrons that can be accommodated in a shell is given by 2n square. याद रहे, this small n is actually the principal quantum number, the value of which is always non-zero, positive integer from 1 up to infinity. Now, what are the rules that have to be adopted during the filling or distribution of electrons? There are 3 rules which have been adopted to distribute the electrons in the subshells or orbital, that are Aufbau principle, number 2 Pauli's exclusion principle, and number 3 is the Hund's rule. Now, first of all, let's start the Aufbau principle. The electrons are added to the energy subshells by the order of increasing energy level. जिसका मतलब ये है कि लो एनर्जी सबशेल्स को पहले फिल किया जाएगा और जैसे जैसे एनर्जी बढ़ती जाएगी इलेक्ट्रॉन्स की फिलिंग उस एनर्जी के हिसाब से होगी. मींस 1s, then 2s, then 2p, 3s, 3p and so on. इसको कुछ हम इस फिगर से क्लियर कर सकते हैं. n here is the principal quantum number, L is the azimuthal quantum number. Now, according to Aufbau principle, the electrons are added to energy levels by the order of increasing energy level. जैसे जैसे एनर्जी बढ़ती जा रही है, means firstly the electron will go in 1s, then 2s, then first in 2p, then 3s, then 3p and then in 4s. Now here the important point is कि 3p के बाद इलेक्ट्रॉन 3d में जाने की बजाय 4s में गया. That is according to the n plus L rule, which later on will be discussed in the electronic configuration topic. After 3d we have 4p और 4p के बाद इलेक्ट्रॉन 4d या 4f में नहीं जाता जबकि 5s में जाता है. The reason here is 4d की एनर्जी 5s से ज्यादा है and according to Aufbau principle जिसकी एनर्जी कम है पहले इलेक्ट्रॉन उसमें फिल किए जाएंगे and then in that is having higher energy. 4d के बाद 5p और 6s उनकी एनर्जी कम है as compared to this 4f, इसीलिए इलेक्ट्रॉन पहले 5p में जाएंगे फिर 6s में and after that they will go in 4f and so on. So it all depends upon the energy level. The electrons are added to the energy subshells by the order of the increasing energy level. That is the Aufbau principle. Coming to the second principle, that is the Pauli's exclusion principle. According to Pauli's exclusion principle, it is impossible for 2 electrons residing in the same orbital of a Pauli electron atom to have the same values of 4 quantum number. इसका आसान अल्फाज में मतलब ये है that the electrons in an orbital must have opposite spin. No 2 electrons in the same orbital can have same set of the 4 quantum number. For example, let us discuss the case of helium, which has 2 electrons. Now, the 2 electrons of helium will be present in the lowest energy level, that is 1s. These orbitals must have an opposite spin. Means एक को हम इस तरह शो कर रहे हैं तो दूसरा ऑपोजिट डायरेक्शन में मीन्स ऑपोजिट स्पिन के साथ मौजूद होगा। हम इसको इस तरह से या इस तरह से शो नहीं कर सकते। दिस इज नॉट अलाउड अकॉर्डिंग टू द पॉली एक्सक्लूजन प्रिंसिपल। दिस इज अलाउड। Let us write the four quantum numbers for both electrons of helium, that is N, L, M, S. We are writing it for helium. For the first electron, N will be 1, L will be 0, magnetic quantum number will also be 0, and spin, let us say that it is plus 1 over 2. Now for the second electron, N again will be 1, L 0, M also 0. Now the spin will be minus 1 over 2, which means that the orbital containing the two electrons must have an opposite spin. Yeah, we can say that no two electrons in the same orbital can have same set of the four quantum number, and that is according to the Pauli's exclusion principle. Now coming to the third rule, that is the Hund's rule. Now, if the degenerate orbitals are available and more than one electron are to be placed in them, they should be placed in separate orbital with the same spin. Important point. Rather than putting them in the same orbital with the opposite spin. Let us consider the example of carbon with an atomic number 6. Let's write its electronic configuration. 1s, 2s, 2px, 2py, 2pz. Now let's write the electrons. In 1s, 2 electrons with opposite spin. 2s, again 2 electrons with opposite spin. यहाँ तक 4 इलेक्ट्रॉन मुकम्मल हो गए। अब हमारे पास बच गए 2. Now according to Hund's rule, इन 2 इलेक्ट्रॉन को एक ही शेल में ऑपोजिट स्पिन में रखने की बजाय means like this, it is better to place them in separate orbitals with the same spin like this. 2pz remains empty. This is an example of the application of Hund's rule. Let us consider another example of nitrogen with an atomic number 7. Again 1s, 2s, 2px, 2py, and 2pz. Let us write the electrons in them. That is, in 1s, 2 electrons with opposite spin. That is according to the Pauli's exclusion principle. यहाँ तक हमारे पास 4 इलेक्ट्रॉन मुकम्मल हो गए। क्योंकि 2px, 2py, 2pz degenerate orbitals हैं, means orbitals having same energy, तो हम पहले एक एक इलेक्ट्रॉन इन तीनों में रख देते हैं। Now here we have completed the 7 electrons. हमने किसी भी एक सबशेल में इलेक्ट्रॉन को इस तरह से नहीं रखा in 2px, 2py and 2pz. Means electrons are not placed with the opposite spin in the same orbital. We have placed them in separate orbitals with the same spin. And that is according to the Hund's rule.